Hi guys, so we are going to go over F.LE.1.3. So this is an example of a standard, and I brought it up on another slide so it's a little bit bigger. It says graph f of x equals x squared and g of x equals 2 to the x power for x is greater than or equal to 0. All this part means is that we're only talking in quadrant 1. Okay, so you're only going to pick x values that are greater than or equal to 0. State which function, f of x or g of x, has a greater value when x equals 20. Justify your reasoning. So justify your reasoning can mean a couple of things. Either you can show it via graph or you can show it via algebraically. So I began to show it algebraically and then we're going to use that to graph it. So I was just working with f of x equals x squared. All you do is you're going to pick x values. I picked some small ones, x squared, and our y values. So when I plugged 0 in for x, 0 squared is 0, 1 squared is 1, and I'm just going to continue the pattern. 2 squared is 4, 3 squared is 9, 4 squared is 16, and 5 squared is 25. So we can go ahead and graph these. So we have 0, 0. I have 1, 1, 2, 1, 2, 3, 4, 3, 1, 2, 3, 4, 5, 6, 7, 8, and 9. I don't know if we are going to go this high. 4, 1, 2, 3, 4, 5, 9. Okay, so I went 4, 16, and at 5, 25 is not going to fit on the graph, so I'm not going to plot it. So we have it graphed, and now I'm also going to plug it into here. Because it also says, well, let's justify a reasoning when x equals 20. So I'm going to plug 20 in. So 20 times itself is 400. Okay, so when it says graph f of x, this, and I'm really sorry if it's a little sloppy, this is f of x. So I'm going to choose a different color. Let's graph g of x. And we'll do this one in red. So we'll do g of x is here. All right, so once again, all we're going to do is we're going to pick x values. We're going to plug them in, and we're going to get y values out of it. So this is our formula for g of x is 2 times that power. So okay, so I'm sorry. So I'm going to do the same thing. I'm just probably going to pick 1 through 5. Wow, apparently I'm going to skip numbers. Sorry. 1, 2, 3, 4, 5, and then I'm also going to do 20 because it says it wants to know which one is the bigger one. So let me get my calculator. So we have 2 to the 0 power. Anything to the 0 power is 1. We have 2 to the first power, which is 2. 2 to the second power, which is 4. 2 to the third power, which is 8. And then we have 2 raised to the fourth, which is 16. And then we have 2 raised, oops, I'm typing in 2. And then 2 raised to the fifth power is 32. So now let's go ahead and do 2 raised to the 20th. Okay, so if I did 2 raised to the 20th power, and just be ready for this, 1,048,576. It's a really big number. So we can go ahead and graph these. So we have 0, 1, 1, 2, 2, 4, 3, 8, 4, 16, and then obviously 5, 32 is not on here. So, again, let me draw my graph. All right, so when it says which one has the greater value, it has to be g of x, because when we plugged in 20 in for x, we got a much higher number than if we plugged in 20 in for here. And the difference between the two was the greater the exponent, the faster it's going to increase. So when the exponents get greater, it's going to go up a lot faster. Alrighty, so moving on to question number 2, we're going to read through it. I don't know if we're going to finish it in my recording. It only lets me record 15 minutes, so if we don't finish this, it'll just be in the part 2. During the first day of a canned goods drive, Jasmine's homeroom teacher collected 2 cans. During the third day, the teacher collected 8. Let D represent each collection day. Let N represent the number of cans the goods collected on that day. Part A. Based on the situation, Jasmine claims that the number of canned goods collected can be modeled by an exponential function. What is the number of canned goods collected on the 6th day based on an exponential model? So what she's talking about in an exponential function. So what that means is we are going to have something, a number raised to another. Okay, so for example, on the first day, she collected 2 cans. So we can do 2 cans raised to the 1, and that'll give me 2. So there were, this was the day. So, sorry, D is the day, and our N, which is what we're going for, or the number of cans or the number of cans. So let's test this theory. Okay, so if we go in the third day, if we change that to a 3, is it how many cans they collected? And it is, because 2 to the 3rd power is 8. So far, Jasmine is right. So what it says is let's N represent the number of cans collected that day. Now, on the 6th day, which means we're going to change the exponent again. So we are going to use this number 6. So 2 to the 6th power and 2. I have my calculator is what I'm doing. 2 raised to the 6th is 64. Oops. That's a weird 6. All right, so what is the number of canned goods collected on the 6th day based on an exponential model? Would be 64. All right, so Ramon disagrees with Jasmine. He claims that the number of canned goods collected can be modeled by a linear function. So what that means is from day 1 to day 3, and we have number of cans went from 2 to 8. Okay, so we had our days over number of cans. So we have 2 over 4, which is 1/2. So it's saying that it's growing. So for every day, they're collecting 2 cans. So if they started out with the first day collecting, so at 0 days they had 0, day 1 they had 2 cans. So we are going to create a little chart to kind of help us figure this out. So it's saying it's every 2 days that go by, 4 cans are added, or every 1 day that goes by, we're going to add 2. I just simplified our slope. So for example, on day 1, we had 2 cans. These are days, 4, 5, and 6. Now to go this way, every day we're going to add 2 cans. So 4, 6, 8, 10, and 12. So here is saying on the 6th day, if we use a linear model, we would have collected 12 cans. So let's look at our answers. The number of cans predicted to be collected on the 6th day using a linear model is greater than what's predicted on exponential. That's not true. And if you think about it, exponential functions are going to go up a lot faster than a line. So if you have a graph, an exponential function is going to increase this fast versus a line is going to do about this. Exponential functions get higher a lot quicker. The number of cans predicted on the 6th day using a linear model is less, so that is true. So that one works. Let's make sure all the other ones don't. The number of cans predicted using a linear model is equal, so that's not true because we know that linear and exponential functions are not the same thing. There's not enough information to determine. Well, that's not true. We do have enough information. So your answer has to be B. All right, so let's see if I can fit this in 4 minutes. Alrighty, so for further practice with this standard, LE.1.3, you can always go to USA Test Prep, click on Resources or Other Tests if you're in 8th grade, and find your Algebra 1 EOC. It'll bring up all of the standards that are covered. Use your dot ranks to help you practice. So you've done assignments based on these standards already. So if you're the red or the purple, you want to go ahead and click that. This will pop up. You can do questions, take practice questions, practice vocabulary, do performance tasks, watch videos, play some puzzles. Your dot rank will increase based on questions or performance tasks or puzzles that you complete. Watching videos won't adjust it, but they're very helpful so that you can answer your questions or performance tasks.